Hi, welcome to this demonstration of Diffblue Secure. Diffblue Secure is a work in progress coming out of Diffblue Labs, and we're going to be showing you the current state of play. Diffblue Secure is an application security tool. It will find vulnerabilities in your code. These are real vulnerabilities. These are not false positives. You may be used to using other products where you get pages and pages of reports and you have to go through trying to find the actual vulnerabilities. There are no false positives when you use Diffblue Secure with a valid configuration file for your application. And not only that, but Diffblue Secure provides guidance on how to fix your code, and we're going to be looking at that a bit later. The way it does that is it generates a code trace. The code trace will not only show you exactly where the problem is, but it will also give you hints about how to solve it, where the remediation should go in your code. Diffblue Secure offers integration with CI platforms, so today we're going to be demonstrating integration with Gitlab. If you're using Jenkins or GitHub, the integrations are pretty similar. And so let's dive in. So we are going to be running over a project called WebGoat. This is a fairly well-known demonstration of security vulnerabilities, so we will be expecting to find vulnerabilities in this application. We have a fork here of WebGoat, which we've created in our own repository. We've done that because we created a Diffblue demo branch. What have we put in this branch? Not a lot. So it is pretty much just WebGoat. There's a couple of things. If you're used to GitLab, you'll be familiar with the GitLab CI YAML. This file just tells GitLab what to do in its continuous integration. So we're telling it run our Diffblue Secure product. And then there's a quick configuration file which you have to put in just to say what to analyze. Now, to demonstrate this, I've created a feature branch in the WebGoat repository on GitLab, which has a fix for the SQL injection attack. So I just need to push this branch up to the repository in order to start a CI run. So that will now kick off a CI job. So if we look at the pipelines, we should see a new CI job. It's been created. And we can go in there and see the status on it. Okay, so that job's been picked up by a runner and is now going ahead. We'll leave it to go and come back to us once that's finished. Here's the 3 vulnerabilities that it's found. This last one, we've got one that's SQL injection and 2 that look like the XXE. So let's dig into one of these. So if we click on this last one, this is an XXE vulnerability. We can see where the file is that the problem was found in, and this is the location of the actual sink at the end of the trace. And if we go in there, then we will get to the GitLab interface to that file, and yeah, we can see the actual file there in the line where that sink was. So the problem was caused when the unmarshaller unmarshalled an object which would have evaluated the stream reader which contained the tainted string that was passed in. So let's see what else we can see. Now, this link here is a link into the actual Diffblue Security Tools trace view. And this is going to show us the actual trace of the code that demonstrated this thing, and it will allow you to step through it. Now, this is static analysis, this isn't dynamic, so we can actually move forwards and backwards here, not just forwards through it. And the other thing that we get here is the ability to be able to actually see the value of variables at different points in the code. So as I jump here into this parse XML, what we've got is that the string coming in is the vulnerable string that's been created from the user's input, and it's going to create a stream reader using this factory. And this factory, as you can see, is being created is supporting external entities to true, which means any external entities mentioned in the XML will be instantiated. And of course those could be anything because the XML has come from the user. So that's why we've got a problem. Let's just step through and see that. So I'm just scrolling down here through this stack trace view on the bottom left. On the top left up here, we're seeing the value of the variables that the analysis knows about at this time. So we've still at the moment just got this XML string that is a tainted string. As you can see, a couple of lines down, that's going to get passed in to this function and create a potentially tainted stream reader. And then after that, we're going to have the point where the unmarshaller is called using that stream reader, and that is the final step in the trace because that is the actual sink. And so what we've been able to do, as I said, we can go back through this. What we've been able to do is to show not only that there is definitely a problem, but also where would be a sensible place to do the analysis by stepping through just the code that is relevant to the trace that goes to the thing. So obviously in this case, you'd want to stick a sanitizer on the XML string before this point. So what we showed you is the running of Diffblue secure in a Gitlab environment. As I said, other environments would be fine as well. And we've used it to analyze an application that's shown 3 traces, and we've looked into one of those, shown the actual trace of the real vulnerability, shown why it's a real vulnerability, and how seeing that trace enables you to know how to fix it. If you have any questions, do please email or call us, and we'd love to speak to you further about this product and help you to use it in your own applications.